First of all, you know that the gravitational field strength, the relationship of the gravitational field strength is given by G m over r square, and that relationship is valid when r is greater than equal to the radius of the planet. Okay, this relationship is only valid when you are observing gravitational field strength away from the surface of a planet. Okay, so this is not valid inside the planet. Inside, you know, gravitational field strength is proportional to r, that is for inside. Okay, so from this relationship you can say G is some constant. Right now my focus is not to derive the relationship of gravitational field strength inside the planet, but I can tell you that inside the planet gravitational field strength is some constant time radius, that is r is the distance of a point from the center of the mass, and this is only valid when you are observing gravitational field strength inside the planet. Okay, so when you want to find gravitational field strength at the center of the planet, then you will use this relationship. When you are observing gravitational field strength or finding gravitational field strength, let's say at 5 kilometer or 500 meter away from the surface of the planet, then you will have to use this relationship. Okay, so from this relationship, it is clear that gravitational field strength is inversely proportional to r. So let's draw the gravitational field strength due to this mass. We have this mass, you can see from the diagram, we have this mass m, and that mass has mass m. So we have to plot the gravitational field strength away from the surface of this planet. You can see from this relationship the gravitational field strength is inversely proportional to r square. So as r increases, you can easily say that the gravitational field strength will decrease. It will follow inverse square law. So if you will double the distance, gravitational field strength will decrease by a factor of 4. So let me draw this. Let's say you are on the surface of this planet, and on the surface you will have some value, that is, let's say this is g naught. So as you move away from the surface of the planet, as you move here, gravitational field strength will decrease. So it will follow this type of curve, that is inverse square law. So G is inversely proportional to r square. So if, for example, on the surface of Earth, the value of G is, let's say, that is G naught, that this r is the radius of this planet. So at distance 2r, gravitational field strength will decrease by how much factor? Excellent. It will decrease by a factor of 4, g naught by 4. You are observing it at 2r. Then at distance 3r, you can easily predict what should be the value of g. It should be g naught by 9. So inside this planet, g is proportional to r. So that's why if I want to plot gravitational field strength inside this planet, I want to see how does the gravitational field strength varies from the center of this planet to this point. So that is proportional to r, and it will have a straight line relationship. Inside, G is given by this formula, this relationship. So inside, G is proportional to r. This shows G is 0 at the center, and G will increase, and it will become maximum. After that, G will decrease. Okay. So let me ask you a question. What will be when the value of G will be 0? Will it touch this graph, the axis of this graph, at which point I want to ask you a question, at which point the G will be 0. So you can see that G is inversely proportional to R. When you put R infinity, G will become 0. Okay, so that's why we show this graph as parallel to this axis. Okay, now another question, what will be the direction of G at this point? So G, gravitational field strength, is defined as gravitational force per unit mass, and gravitational force is always an attractive force. So the direction of gravitational field strength will be towards this mass. Okay, so as you move away from the surface of this planet, gravitational field strength will decrease. You can see this from this graph, and eventually it will become 0 at infinity. Okay, so now let me ask you a question. What will be the direction of G at this point? Okay, that's great. G will be directed in this direction. It's an attractive force. So if I am saying this G, if I am taking left side direction, G is a vector quantity. If I am saying this is a positive, I have taken these values as positive. So over here on this side, G will be negative. This is my sign convention. I have taken left direction as positive. Okay, then the right direction should be taken as negative. Now you think about how to draw the graph on the left side of this planet. Okay, let me help you. So on this side, the graph of G will look like this. It's a straight line portion, and then G will be like this. So this is how we plot the graph of gravitational field strength on both sides of this mass. Okay, and the gravitational field strength you can see is 0 at the center, and as you move away from the surface in this direction, the magnitude of gravitational field strength will decrease. Remember that the sign of a vector quantity, the negative sign of a vector quantity shows the direction. Okay, this doesn't mean that if this value is smaller than this value. No, the value over here is greater. As you move away, the value will decrease, and eventually it will touch this axis on infinity. This is how we plot the graph of G with respect to R. Now let's assume we have two masses. This is M1 and other mass is M2. And now we want to plot a gravitational field strength between these two masses. For example, if I pick a point over here, the gravitational field strength due to this M1 will be in which direction? That will be, okay, that's good. That will be towards left. And due to this mass M2, that will be in, let's say this is GM2, this is GM1. So gravitational field strength due to this mass will be towards left, and due to this mass will be towards right. So there will be a point between these two masses where the magnitude of these two values will be equal and they will cancel each other. So in between these two masses, there will be a point where the total gravitational field strength will be 0. Okay, so now I will draw the gravitational field strength due to these two masses. So first of all, I have to decide my sign convention. You can see, let's say I choose this sign convention. I take left as positive, then I have to take right direction as negative. Okay, so gravitational field strength due to mass M1 will be towards left, and that is taken as positive. So let's draw it. It will start from some maximum value, and it will decrease. It will follow inverse square law and it will decrease. That's how the gravitational field strength due to mass m1 varies. It has some maximum value over here and it decreases, and it becomes least as you move away from this mass. Okay. So right now, what we are doing, we are plotting the gravitational field strength due to these two masses between the surfaces of these two masses. We are not going inside of these masses. We are considering these masses as point masses. So that's why we will not plot gravitational field strength over here in this region. Okay, in this region. But you can think about that. So that is gravitational field strength due to this mass m1. So what about gravitational field strength due to mass m2? That will be towards a right direction, and right direction is taken as negative over here. So gravitational field strength due to this mass will start from some maximum value and it will decrease and it will go in this way. Okay. So the magnitude of this value and this value depends on the size of the masses. Okay. Let's say if these two masses are equal, then they will start with the same magnitude. If m2 is smaller than m1, then this value will be smaller then this value will be smaller than that value. Okay. You can see from this graph, this has some maximum value over here. The value decreases. Eventually, it will become very small. So now we have to plot resultant gravitational field strength due to these two masses. We know both the gravitational field strengths due to mass m1, that is due to m1, g due to m1, and this is g due to m2. Now we will use the point by point addition method to find the net gravitational field strength. Let's say, let me give you an example. Let's say I want to find gravitational field strength at this point. At this point, you can see at this point it has some positive value, and due to this mass, it has some negative value. Let's say this value is 100 for your ease, and this value is minus 10. So what will be the resultant of gravitational field strength at the surface of this mass m1? That's good. 100 minus 10, it will be 90. So let me change the color. So at this point, it will be starting with this value, some value less than 100, and it is 90 for if you assume this 100 and this minus 10. So as you move away from this mass, you can see there will be a point where these two masses, where these two values will be equal in magnitude. So over here, resultant will be 0. Positive value, negative value, they have equal magnitude. So when we will add these two, we will get 0. Okay, that's great. So now, let's say I want to find resultant at this point. Can you see? Over here, you have a negative value, and over here, you have a positive value. So that's why net will be somewhere here. This is resultant. Okay. So this is the resultant. I'm sorry. So at this point, resultant will be 0. So now I can sketch the graph of the resultant. So resultant will vary in this way. It will go to 0. And then after this point, if you want to see at this point, can you see this? This is a positive value and that is negative value. Let's say this is 10, this is minus 30, the greater value. So what is the sum of these two? That's good. This is minus 20. Okay. So the resultant of these two will be minus 20 and that will be on the negative side. So now the resultant will vary in this way and at this point it will be somewhere here. So you can see how the resultant varies. Over here resultant has greater value, it decreases, resultant becomes 0 at this point, and then the direction of net gravitational field strength changes and the magnitude increases, and it is maximum at that point. This is how the net gravitational field strength changes with position x. So that is G net. So let's mark this point. Let's say this is point A. So at this point, the gravitational field strength is 0. So if you place some object over here, will it experience any force at point A? No, because if the gravitational field strength is 0, the force is the mass of object time gravitational field strength. If the gravitational field strength is 0 at point A, then the force on that object must be 0. In this region, in this interval, for example, I am talking about the gravitational field strength from this point, from the surface of this mass to this point. The gravitational field strength decreases. It is positive. Positive means the direction is towards left. If you want to find the net gravitational field strength at this point, it will be towards left. At this point, it will be towards left, but the magnitude will decrease. At that point, it will be towards left. At this point, it will be 0. But after that, gravitational field strength will be towards right direction and the magnitude will increase. Okay. So from the surface of this planet to point A, the net gravitational field strength is towards mass m, and after point A to the surface of this mass m, the net gravitational field strength is towards mass m2 or towards a right direction. Okay. So the net gravitational field strength is plotted like this. So in exam, if you are supposed to draw the net gravitational field strength, then you will have to draw only this curve. And I will leave a question for you. If you change these sign convention, if you put left side as negative, if you take this as negative and that as positive, then what will be the change on this graph? What will be the shape of net graph? And what will be the shapes of G due to M1 and G due to M2? Okay. Now I want to draw a graph of net force. Let's say I have a mass over here. I will place a mass somewhere here on this point. Let's say mass M moves from this point towards the surface of this mass, moves from here towards the surface of that mass M2. How does the net force will change on that mass? Okay, we will provide some speed to this mass so that it can move towards mass M2. Why? The direction of net force or net gravitational field strength is towards left. So without providing the speed or energy, it can't move up. Okay, if we leave any object somewhere here, it will go in that direction, okay, towards the net force. But if we provide some energy or speed, then it will move up. So the speed of this object will decrease, the net force in the backward direction. As it reaches at that point, then the direction of net force changes towards the right direction, and then speed increases. So we want to plot how does the net force on that mass varies as it moves away from the surface of this mass. Okay, this is my last graph. So I want to plot how does the net force on that mass changes. Okay, I hope you can understand. So over here, I want to plot net force on that mass, this mass M, that moves from this surface towards the surface of that mass M2. Okay, so net force is equal to MA, and over here the force on an object in gravitational field strength will be mg. This is gravitational field strength. Okay, so as does the gravitational field strength changes, the force on that object must change. So over here, the net force on that object will be maximum, and that net force will decrease it will become 0, and then net force will increase in the other direction. This is curve, this is not straight line portion. Okay, let me draw it again. The net force will this is how the net force on this object changes. The net force is maximum at that point because G is maximum. Then net force decreases, it becomes 0 at that point. Then the net force increases in other direction. Okay, so this is how the net force varies, and the net gravitational field strength between these two masses varies. Okay, I hope this video was helpful for you. So if you have any question, you may ask your question by commenting on this video. I will be there to help you. Thank you so much.